We're going to mix together two solutions. One's 0.4 molar cobalt 2 chloride, the other one's 0.4 molar sodium hydroxide. How would we physically make these solutions? How would we tell the beginner, the neophyte, how to make them? We would tell them we have a fraction of a liter, 0.2 liters, and in every liter there's 0.4 moles per liter. So we only need a fraction of 0.4 moles. We need 0.08 moles. If we consult the periodic table, there's 40 grams in 1 mole, so 0.08 moles would be 3.2 grams. We're going to add that 3.2 grams into a beaker or something we can eventually measure the volume of, and then add water up to less than 200 at first. Stir it in and then add a little bit more to make sure it fills 200 milliliters of the solution, which is the solute and solvent combined. We're going to have this drop scheme here of more sodium hydroxide and less cobalt to start with, and we're going to increase the concentration of cobalt, decrease the concentration of the hydroxide ion as we go from test tube 1 to test tube 5. The cobalt ion and the chloride ion are the only little catch here is that the chloride ions is going to be twice the concentration of the cobalt ions because of the charges. So here's what it looks like. You notice that there's a nice precipitate in each of these, excess of cobalt ions on this side and excess hydroxide ions on this side, and we'll discuss what's in the middle here, and will lead to that understanding as we look at the individual amounts of moles present. So if we look at the test tube 1 as an example, every sodium ion hydroxide ion 1 and we know that we had 42 drops, so there's 20 drops in a milliliter, so this would be the number of liters. And since there's 0.4 moles in every 1 liter, this is the number of moles of sodium ions and hydroxide ions in test tube 1. Similarly, in test tube 1, we have 6 drops, so we're going to have the same algorithm exactly. Don't hesitate to use it. This many moles, 0.00012 moles of cobalt ions, and twice the number of chloride ions. If we want to look at moles of precipitate, you notice 1 cobalt ion and 2 hydroxide ions make 1 unit, as it were, of cobalt 2 hydroxide. So we know that in test tube 1 we have this many moles we've previously seen of cobalt ions, this many moles of hydroxide ions. The question is how many moles precipitate? Well, if it's 1 and 2 make 1, then we're going to use this many moles of cobalt, all of it, and only a fraction of the hydroxide ions to make that many moles of precipitate. None of these left over, this many left over, and so to calculate the molarity of the excess, in this case the hydroxide ions, we put the number of moles over the total number of liters, which is always the same in each test tube, and the chloride ion, the spectator ion, the total number of moles over the total volume.